I am using from the Andhra Cements. The Andhra Cements, there is a fly ash with them. So they are providing, even if you provide only the transportation charges, they are ready to give the fly ash because it is a dumping problem for them. So, and here, when I am saying it, fly ash means it is a ash. There is a small correction in the collection process. If I am in the collection itself, if I am using any techniques, then I call it as a ground granulated blast furnace slab. It is also a slab, but how you are collecting, based on that we are given different names. Fly ash is it just from directly collecting from the funnel, and we are using this. Mainly what happens in the ashes is they are very fine. So because of this fineness, they are going to spread more area and they are occupying more area, and automatically they are going to fill the voids. Even when I am saying in our regular concrete, we are not thinking about the whatever the voids forming with respect to sand. But in SEC, because we are using these fine, very fine powders, so they are going to fill the even whatever the with respect to sand also some voids are forming that are also filled with the this mineral admixtures. Right. So when nowadays almost PPC we are using. So in that already fly ash content is there, 20 to 25%, and you have to develop a mixed design procedure with respect to that cement. Because when I am using a separate mix, see, I already have developed a SEC mix in the NIT Warangal, but I cannot say the same mix is suitable here because here the sand is zone 4 sand. Whatever the sand I have used in the Warangal is, it is zone 2 sand. Accordingly, now I am guiding a research scholar, Prasenjit Shah. He is developing a SEC suitable to this northeast zone. We are not going to say use the same SEC proportions what I have developed in Warangal, because here the sand is zone 4 sand, and we know that in that so much of mud content, fines are more, and you are not going to get the same strength and all this. So we are trying to eliminate the problem of and even collecting the sand is also very difficult. That's why we are going to replace the sand also. We are trying to give a solution to this zone 4 sand, adding some quarry rock dust, because in that
we are also using this.
You are also using
When we are using crusher dust to improve the gradation of the sand from zone 6
yes.
to zone
2. Okay, good, very nice. And we are also trying for SEC, not for a regular concrete, because here his work is, we decided the work is like that. He is going to develop the SEC, not only the SEC, that SEC should be suitable to this northeast zone, because mainly we are concentrating on sand. We are not replacing the both at a similar time, because if I am replacing aggregate and sand, then it is very difficult to say what is the effect. So that's why first we are trying to replace the sand, and how much optimum dosage I can replace. I cannot say completely 100% I cannot replace. So what is the optimum dosage of replacement of this zone 4 sand, so that it is going to improve its quality and it is going to develop the self-compacting concrete. I will show some videos. What are the tests we are going. See, these are the practical problems. Yesterday also we have seen the PS. They are thickly and heavily reinforced. In that cases, even it is not possible to vibrate. If there is any chance of vibration possibility, then you can vibrate. But there is no chance of vibrating. So in that cases, SEC is going to work better. I will show some tests on SEC. These are all the related theories. Just I will show you. These are the actually for SCC, FNARC is given some specifications. When you are going to say SCC, self-compacting concrete. So for that, mainly we are using 4 tests. One is horizontal flow test. We are not going to take the slump, vertical slump, because it is high workable. High workable means we are not having a limit of 100 mm slump, not like vertical. We are going to see in the horizontal direction. Suppose if I am using the same slump cone, same slump cone is used here. If I am lifting that slump cone, it should flow horizontally minimum 600 mm. Then I am going to say it is the, because I am checking its passing flowability. That means just lifting the cone by its own weight, if it is able to spread 600 mm width, then I can say one test is it is passed, that is flowability. Similarly, we are going to have another test is called gearing test. So gearing means here I am going to keep the ring. In that I am going to use this cone and I am going to lift this cone. After lifting this, inside the ring, outside the ring, the height difference should not be less than, it should not cross 10 mm difference. If I am measuring inside the ring, outside the ring, the height difference, because if there is a height difference means it is not flown properly. Even why I am keeping this gearing means because in practicality you are going to have some obstruction. That obstruction is the reinforcement. So I am going to keep the same similar obstruction and I am trying, even if I am putting some obstruction, how it is going to flow. Even these videos I can show you. See how it is going to flow. It is a horizontal flow, not the vertical flow. So that dia, if I am taking, it should take minimum 600. The code says it should flow minimum 600 to 800 mm. Like that, we have to design. Similarly, we have a gearing test. So in this gearing test, suppose if I am lifting the cone, it is also going to flow, but inside the cone and outside the cone, if I am measuring the vertical heights, the height difference should not be 10 mm. That means that even if some obstruction is coming also, it is ready to flow. That is called passing ability. One is flowability, another one is passing ability. Similarly, we have segregation resistance test. That means segregation means if I am keeping the concrete for 5 minutes, 10 minutes, just like that, if it segregates generally. If I am keeping the concrete just in a container for 5 minutes, generally it is going to segregate. But here we are going to test even if I am keeping it 5 minutes just like that only, it should not segregate. For that we are going to use this V funnel. In this V funnel, first what we are going to do is I am totally filling this V funnel and there is a opening arrangement. If I am opening this V funnel, it should empty the V funnel within 6 to 12 seconds. If the concrete is able to empty the total volume of this V funnel within 6 to 12 seconds, then we can say it is a self-compacting concrete. It is not going to, that is one passing ability. Another test is, once again I am going to fill this V funnel and I am keeping for 5 minutes in that. Then I am going to open this. If then I am giving it chance to flow, at that time, the time difference, let us say initially it is taken some 8 seconds to complete the V funnel. Next time, after waiting 5 minutes, it should not cross plus 3 minutes extra. That means initially it is taken 8 seconds, it should not take 8 plus 3. That is 11 seconds. Within the 11 seconds, it should finish. Suppose after waiting 5 minutes also, it is finished emptying the thing within 11 seconds, then I can say no segregation. So like that, if it is satisfying all these tests, then only we are going to give a brand as self-compacting concrete. Nowadays, we are having flowable concretes. See, in the site, I asked them, they are using the flowing concrete. There is a small difference between the flowing concrete and self-compacting concrete. We are adding some retarders so that they are going to keep some 45 minutes or 30 minutes based on your site place to execution site to the where you are preparing this concrete. Accordingly, we are going to add the these chemicals. So if you are adding that chemicals, they are going to keep until 45 minutes. It is still in the flowing stage only, and they are using these pipes and they are going to keep the concrete. But there the compaction is required. It is only a flowable concrete, not a self-compacting concrete. Okay, so in this is also one type of U-box test. Similar to that, we are going to keep one side concrete and another side. Here we are having two sides. So first I will fill the concrete, then I will open this one, then it is going to through. That means if it is flowing from one side to another side, because it is concrete is passing through the pipe. Even if it is passing through the pipe, even some vertical directions are there, then also it should pass. Like that also we are testing. That height difference should not be greater than 30 mm in that case. then we are going to say it is the SCC. So for the mixed design, these are the FNARC specifications. European Federation is given some specifications. They says that if it is a slump cone, minimum maximum, it should be within these limits, 650 to 800 mm. That's slump cone. Similarly, T50 centimeters seconds. When I am saying horizontal flow, because all these are related to the shear, viscosity and shear. When I am saying with respect to concrete, this slump flow and all this we are saying with respect to that. Even if we are measuring with respect to time also, to flow that 500 mm diameter, it should take 2 to 5 seconds. It should not take more than the 5 seconds. Like that, by using these mixed proportions, we are going to say these are the some mixed proportions I have developed for M20, M25. Even I can use the ACI method or IS code method. Initially, I can start with that, but you have to go for trials. Actually, we are following a Nanshu method of mixed design. If you are following Indian code, these are the proportions you are getting. But to get these proportions, you have to go for so many trials. And that too, see, I am saying this is if I am developed this in NIT Warangal, it is not suitable in NIT Silchar, because here again I have to go for the trials based on the material availability. Another thing, just 2 minutes I want to spare. Another thing is not only the self-compacting concrete, because nowadays we are seeing the curing also. Curing also a big problem. Actually, if it is cured for 28 days, then only it is even whatever the material you are using, whatever the quality of cement you are using. But in all government practices, I think no one is going for 28 days curing. Simply they will go for minimum of 7 days or 14 days maximum. So this is also a practical problem. So that's why now we are also working on self-curing concrete. Similar to this, we are going to add some epoxy coatings or polyethylene glycol, that is the chemical. So with that, whatever the chemicals they are having, this polyethylene glycol, we are going to add this. Then no need of any curing. Even the practical tests we are doing here. Suppose if I am preparing one concrete with curing, another one is just like our practicals, I am preparing and I am leaving it. Another one is I am using this polyethylene glycol chemical, then I am also not curing it. It is self-curing, no curing, and curing with water. Like that we are doing, and we are getting the good results even with the polyethylene glycol. Even it is practically is also available. This L&T company is using this self-curing concrete in practice. Even the Lanco is using this self-compacting concrete. Practically in Bombay, in one tunnel, they have used self-compacting concrete, and even now in IIT Hyderabad, the new campus is preparing with the self-compacting concrete. It is slowly coming into the practicality. So, thank you very much for giving for an opportunity to share my ideas. Thank you.